All right, let's see if we can get this guy done here. We're going to find the electric field at point P, right? Okay, so, oh, look at this. This one's kind of zesty. Okay, so this is a positive charge. The electric field is going to be away from it, okay? So it's going to be like this, right? So the electric field of A is in that direction, and then the electric field of B is going to be this way. So let's first find the magnitude of these guys, right? So EA is K times, and then A is 1.3 microcoulombs, right? So 1.3, and then it's over R squared, so it's the square root of, and we're 3 over and 1 down, so 3 squared plus 1 squared. Don't forget though that it's R squared, so really the square root thing goes away, right? So 8.99 E9 times 1.3 E minus 6 divided by parentheses, and I'm really just going parentheses 3 squared plus 1 squared, and I get that it's 1168.7 newtons per coulomb, right? And then EB is equal to K, and B is 3.1, right? So dyslexics beware, okay. 3.1 E minus 6. I really shouldn't write problems like that. That's like a, let's see, it's 2 over and 1, 2, 3 up, right? So 2 squared plus 3 squared, right? So remember, this is the distance formula. Okay, and so I'm going to go up here to this guy. I'm going to go 2 squared. I'm going to change this to 3.1. I'll change that to 2 squared and 3 squared. All right, and that is 22.143 point, I'll just say 8. Right? So now we're going to go EA, EB, right? Okay, the magnitude of A is 1168. Magnitude of B is 2143. All right, now we got to figure out the angle. Ooh, this is tough. Well, let's see. This angle right here, this would be the trig angle, right? If we do this, so that's tan minus 1 of 3 halves, right? 1, 2, 3 here and halves there, right? So second tan, 3 divided by 2. This is for B, right? It's 56.31 degrees, right? And then this guy is, oh, we could use like a negative angle. I'm not gonna, but let's see. So that angle there, if I found that angle, tan minus 1 of 1/3, right? So second tan of 1 divided by 3 is 18.43. Right, now that's not the trig angle. We could go negative 18.43. I'm going to choose to be the gentleman here and say 360 minus 18.43. And that's 341.57. Now feel free to just use negative that, right? I'm just trying to be a good role model here. All right, here we go. All right. So now we've got, let's just double check this. This is the one we got with that. That's the 3 and the 1, the 1.3. Right, and that's it, and that's there. And then, oh yeah. Okay, so then that one would be at that weird angle, right? Okay. And then B is this guy that I got with that, and that's going to be up and to the right. Do I have that right? This is good, because the rest of this isn't very hard. It just is sort of sad if you mess up this thing, right? Okay, so again, this cos this is this. So let me go find that 1168 guy. There it is. Cos this thing is 1108.73. Indeed, it has a positive x. We expect this to be a negative y, though, right? All right, so here we go. So now I'm going to go up here. I'm just going to change it to sine, right? Whoa, whoa, come on, baby. Sine. Negative 369.58. Right, so it's a smaller y component. We would expect that. Big X, smaller y. This makes sense. Okay. I'm happy to be part of this plan. Okay. Now let's see. We've got 2, 1, 4. Cos 56.31. See if I can find that angle. Come on, baby. There it is. I'll have you know I'm not rounding at all. 1189.15. Let's see, positive. Does that make sense? Yeah. Wow. So it should have a bigger y component. Let's see. I did cos. Okay, so let me just go up and do that guy and make it sine. Woo. This up arrow thing is like it's like changing. Okay, 1783.72. All right, now we're all set. Now we're going to go. All right. Let's draw boxes. All right. So now we just add this to this, right? So 1108.73 plus 1189.15. We're carrying a ridiculous number of sig figs. All right. 2297.88. All right. And then this guy is the opposite of 369.58 plus 1783.72. And that's 1414.14. Oh, that makes me happy. All right. And now we just have to draw this guy. It's a lot of over, and then sum up. All right, this is 1414.14. Just makes me happy. 2297.88. And then the vector is, let's see if we can do it. Come on, baby. Oh, it's so hard to draw the diagonal line, but I did it. All right, square root of 2297.88 plus 1414.14 squared. Let's see if we can find that. Square root of this guy squared plus this guy squared. The bell rang. 2698. 98.2, right? And that's newtons per coulomb is our magnitude, and that's agreeing quite well with this answer, right? And then let's find this angle here, right? That's going to be the tan minus 1 of 1414.14 all over 2297.88. So let's go second tan of that guy divided by this guy. And that's 31.6 degrees. So that is our angle. This is our magnitude, and that's all there is to say, folks.